Welcome to Spaceverse, your portal to cosmic adventures. It's the reddest, dustiest red supergiant that we've ever seen explode as a supernova. For decades, astronomers have been searching for a missing population of doomed stars, the massive red supergiants that, according to theory, should end their lives in powerful explosions. But strangely, these cosmic titans seem to vanish before their spectacular finales. Now, with the help of the James Webb Space Telescope, that mystery might finally be clearing up, both figuratively and literally. A new study has just captured the most detailed look ever at a red supergiant right before it exploded. Using JWST's unmatched infrared vision, astronomers were able to identify the exact star that produced a supernova, marking the first time the telescope has directly spotted a supernova progenitor. The discovery, published in the astrophysical journal Letters on October 8, suggests that many of these enormous stars do explode. They just hide behind thick veils of dust that obscure them from view. Charlie Kilpatrick of Northwestern University, the lead researcher, said, "We've been waiting for this to happen, for a supernova to explode in a galaxy that JWST had already observed. Only now, with JWST, do we finally have the quality of data and infrared observations that allow us to say precisely the exact type of red supergiant that exploded and what its immediate environment looked like." The supernova, named SN 2025 PHT, was detected on June 29 in a galaxy about 40 million light-years from Earth, not too far in cosmic terms. Conveniently, both JWST and the Hubble Space Telescope had already captured images of this same region. Hubble's images dated back to as early as 1994, while JWST observed the site twice in 2024. By carefully comparing these before images to those taken after the explosion, Kilpatrick's team pinpointed the specific star that detonated. They posted their initial findings on the preprint archive arXiv on August 14th, before the official publication. To make absolutely sure they had the right star, the team meticulously aligned the Hubble and JWST images using 36 reference stars visible in both sets of data. Each pixel had to match perfectly, ensuring that the scientists were looking at the exact same spot in the sky across decades of observations. When they compared the pre-explosion images to the ones taken afterward, they found one bright, point-like source that appeared in all of JWST's images, exactly where the supernova later showed up in Hubble's post-explosion photo. This left little doubt. The object visible in those earlier images was the progenitor star that became SN 2025 PHT. But what made this star so special was its appearance. It wasn't just bright, it was extremely red. So red, in fact, that it was clear it was shrouded by a thick cocoon of dust. Despite shining about 100,000 times brighter than our sun, its visible light was dimmed more than 100-fold because of the heavy dust surrounding it. Co-author Aswin Suresh, a graduate student in physics and astronomy at Northwestern, remarked, "It's the reddest, dustiest red supergiant that we've seen explode as a supernova." This discovery suggests that the lack of visible red supergiants in previous data wasn't because they didn't exist, but because telescopes like Hubble, which primarily detect visible light, simply couldn't see through the dust. JWST, however, views the universe in infrared, which can pierce through thick cosmic clouds, revealing what optical telescopes miss. Kilpatrick added, "That tells us that previous explosions might have been much more luminous than we thought because we didn't have the same quality of infrared data that JWST can now provide." To understand the significance of this discovery, we need to talk about what red supergiants are. These are massive stars, typically 8 to 25 times the mass of the Sun, nearing the end of their lives. They have swollen to enormous sizes, sometimes hundreds of times wider than the Sun, glowing with a deep crimson hue as they burn through the last of their nuclear fuel. When the core runs out of energy to sustain fusion, gravity takes over, collapsing the star's heart inward. The result? A supernova, one of the most powerful explosions in the universe. Afterward, what's left behind depends on the mass of the star. Smaller red supergiants collapse into neutron stars, ultra-dense remnants where a single teaspoon would weigh billions of tons. Larger ones collapse all the way into black holes, where gravity becomes so intense that not even light can escape. The most famous red supergiant of all is Betelgeuse, the bright red star that forms the shoulder of the constellation Orion. Astronomers believe Betelgeuse could explode sometime within the next 10,000 to 100,000 years, a blink of an eye in cosmic time. When it does, it will shine as bright as the full moon and be visible in broad daylight from Earth. But here's the problem that's puzzled astronomers for decades. If red supergiants are supposed to end their lives as supernovae, then why have we seen so few of them just before they explode? Theoretical models predict that these massive, luminous stars should be common among supernova progenitors. Yet, when astronomers looked at archival images of galaxies where supernovae occurred, the progenitors were almost always missing. It was as if the stars simply vanished before they could explode, earning them the nickname failed supernovae. The new JWST findings change that narrative. Many of these missing stars weren't gone at all, they were just hidden behind their own dusty cocoons. Kilpatrick admitted, "I've been arguing in favor of that interpretation, but even I didn't expect to see such an extreme example as SN 2025 PHT. But the surprises didn't end there. When the researchers analyzed the dust surrounding the progenitor star, they found that it was unusually rich in carbon, rather than the silicate-based dust that red supergiants usually produce. This discovery hints at something fascinating happening deep within the star before its death. The team believes that powerful convection currents, similar to massive bubbles of rising gas, may have dredged up carbon from the star's core and transported it to the surface. This would have altered the star's chemical composition in its final years, possibly influencing how it ultimately exploded. That detail is crucial because it suggests that the chemistry of a dying star may directly affect the kind of supernova it produces, and even the elements it releases into space. After all, supernovae are responsible for forging many of the heavy elements in the universe, from iron to gold to uranium. Every atom of calcium in your bones and iron in your blood was once made in a massive star like SN 2025 PHT. So when JWST peers into the heart of a dying star, it's not just watching a death, it's witnessing the creation of matter that will one day become planets, life, and even us. This discovery does more than solve a long-standing mystery. It opens an entirely new window into how massive stars live and die. With JWST's infrared vision, astronomers can now see through the dust that hides these final moments, capturing details that were once impossible to observe. And the timing couldn't be better. NASA's upcoming Nancy Grace Roman Space Telescope, set to launch in the next few years, will complement JWST by surveying huge areas of the sky with unprecedented depth. Together, they'll allow scientists to track even more of these hidden giants and catch them in the act, right before they explode. As Kilpatrick put it, with the launch of JWST and the upcoming Roman launch, this is an exciting time to study massive stars and supernova progenitors. The quality of data and new findings we will make will exceed anything observed in the past 30 years. Think about that for a second. Astronomers are now entering a new era where they can literally watch stars die in real time, uncovering how their last breaths shape the galaxies around them. SN 2025 PHT might just be one explosion among billions, but it represents a monumental step forward in understanding the final act of stellar evolution. It proves that the universe still holds countless secrets waiting just behind veils of dust, and that with the right instruments, humanity can finally begin to lift those cosmic curtains. Every new supernova observed by JWST will bring us closer to understanding not just how stars die, but how everything, from planets to life itself, begins. Because, in the grandest sense, every supernova is both an ending and a beginning. And with JWST's eyes now fixed on the cosmos, those beginnings are only getting clearer. So the next time you look up at Orion's shoulder and see Betelgeuse glowing faintly red, remember, someday that star too will explode, and when it does, telescopes like JWST will be ready to watch, record, and tell the story of another sun's magnificent end. The universe is vast, ancient, and full of dust, but now we finally have the tools to see the light shining through. It's a reminder that even in death, stars leave behind the elements that make new worlds and life possible. If you enjoyed diving into the mysteries of dying stars and the breakthroughs of JWST, don't forget to like, subscribe, and turn on notifications so you never miss a journey through the cosmos. This is Spaceverse, where we explore the universe one discovery at a time. Until next time, keep looking up, because somewhere out there, another star's final light is just beginning to shine.